Hello everyone, my name is Esraa. I want to talk about removal of stabilized silver nanoparticles from surface water by conventional treatment process. This characteristic has antibacterial property and it has large amount of attention. This characteristic leads to use AgNP in many products such as cosmetics, wool fabrics, and air and water filters, plus use it in medical equipment and textiles. AgNP may occur in drinking water source either during the manufacturing, consumption, and/or disposal process. All that because of extensive use in many products. This maybe can lead to the presence of AgNP in finished drinking water, which could have public health impact. Information in this paper is limited regarding to the removal of stabilized AgNP by conventional water treatment process. So in this study, three types of stabilized AgNP with different surface property were synthesized. So the purpose of this study is increase understanding of NP fat and transport in potable water. This knowledge is vital due to the potential health risk imposed by NP. Results from this study will enable better prediction of the fat and transport of these materials. According to the mention above, engineered systems could be designed to minimize their impacts. Now we want to talk about materials and methods. All AgNP, Sigma Aldrich والمilwaukee WI suspension were prepared in supercooled water with resistivity greater than 18.3 megaohm centimeter. To obtain the SEM image, zeta size analysis like in figure 2 and study the effect of aluminium on the AgNP. طبعا هاي ال AgNP اللي ذكرناها تم تحضيرها في مياه نهر أوهايو الخام اللي تم الحصول عليها من محطة الضخ السابعة لمياه سنسناتي الكبرى. The second method, synthesis and preparation of the AgNP suspension. It has three branches. Citrate, reduced AgNP, BBB-AgNP, branch البوليإيثيلين stabilized PPEI AgNP. وطبعا كل واحدة منهم مفصل عنا بالفيجرز كيف طريقة استخدامهم وكيف عملناهم يعني. الاناليتيكال method. The hydrodynamic diameters of 3 AgNP determined by dynamic light scattering using zeta Sizer nano series with 633 nanometer laser source and detection angle of 173 degrees. The SEM was used to verify the size and shape of NPS. Element composition of the dried AgNP suspension was obtained using an energy FEI Philips scanning, electron microscope with EDAX software, and electron backscatter between AgNP and the natural water collects. Analytical capability. Chemical content of the raw water was assessed by ICP and TOC. The total solid content was obtained by drying 3 samples 100 at 103 to 105 degrees Celsius for 24 hours. AgNP characterization. كيف تمت هاي الميثود؟ عن طريق placing ال AgNP dispersion in natural water and taking its data sizer curve reading automatically obtained every minute for 30 minutes. Then measure the effect of add alum doses to AgNP suspension in deionized water. The HDD of the 3 AgNP was taken, then monitored for 30 minutes using zeta Sizer. تمام. هلا عن هاي الميثود اللي هي removal AgNP during drinking water treatment. كيف تمت؟ أول إشي ضفنا ال Al2SO4 by 3 بconcentration 20 ملغ لكل لتر على شكل coagulant. ال A, G and B suspension were then studied during four stage رح نحكي عنهم هلا of drinking water treatment, coagulation, folliculation, sedimation and sand filtration. كيف تمت الفور ستيج؟ الأول ستيج was repeat mixing 100 round per minute for 1 minute. Second stage was slow mixing at 30 round per minute for 30 minutes. The third stage was settling for 1 hour. بالمرحلة الرابعة fourth stage the super sand water passed through sand column. All A, G and B treated by three methods. The first method is conventional treatment. The second method direct filtration with flocculation. The third method direct filtration with no flocculation. The difference between one method and two methods is conventional treatment using coagulation and flocculation, settling and sand filtration, but a direct filtration without settling step. The third method اللي هي direct filtration with no flocculation using coagulation and sand filtration without settling or flocculation step. In this figure we show a group of data. In figure 1a, the data suggests that NB dispersion were very stable in natural water. This was due to repulsion forces that emerged between AG and BS and natural colloids in water being treated. It also assumed that the presence NOM increased in surface charge of AG and BS. So the presence of NOM may further stabilize NBS through steric repulsion. This is due to capability of NOM to act as polyelectrolyte in water. But in B, C, and D plus table 2 on next slide, we show that PVP and PP, EIAG, and BS were characterized with high molecular weight, that's 100 replacement by sulfate ion. We mentioned this information in the figure above. In this figure, plus table 2, we show AGV, AG and B zeta potential in raw water. And also we show AG and B charge in DI and natural water with different aluminum concentration. The PP, EI, AG and BS surface charge was changed from 36 plus 36.1 to minus 30.2. This is due to the attachment of the negatively charged background material in natural water. This figure represents AG and B removal during conventional treatment. The data show importance of folliculation and settling step in the removal of stabilized AG and B. More than 85% of initial concentration of PPEI and PVP coated AG and BS was removed during flocculation or settling stage. However, the concentration of the citrate coated AG and BS was not affected by folliculation step. Sand filtration region in this figure show the sand filter, which has actually retained all PPEI, AG and BS. This is due to positively charged surface. in this figure show the attachments over the AG and B on the larger aggregates. So the big particles are coiled in water and the small shiny particles are attached to AG and B. In this figure and the following figure in the next slide represent the data obtained from direct filtration with and without flocculation studies. When we compare the figure 6 with figure 7, we showed that the flocculation formation delayed the BPEI breakthrough in figure 6 when compared to the fast breakthrough in the absence of flocculation in figure 7. Also, we mentioned this information in figure 6 above. About the conclusion, this research, three types of stabilized AG and B different surface properties were synthesized. The AG and Bs were then subjected to potable water treatment methods to investigate their removal efficiency, and the characterization and aggregation studies were conducted on three AG and Bs to confirm their stability in natural water.